Happy Wednesday, everybody. All right, let's jump into this. Today is a review day, so we're not going to learn anything new. We're just going to practice more about mutations, the different types, and yeah, that's about it. Yesterday's riddle, what has no beginning or end or a middle? A donut. Who doesn't love a good donut? And today's riddle is, I can be cracked, I can be played, I can be told, I can be made. What am I? Think about it, text me, put it in a Google Classroom. Let me know what you think. You'll need your notebook, pen or pencil. You're just gonna add a couple notes to your yesterday's notes, but you will need your notes from yesterday just as review to do today's classwork. You can title today Unit 4A, Lesson 11, Mutations number 2, 429. What you need to know for today, again, attendance assignment. If you haven't done that yet, please pause me and come back, but do that first. Your worksheet, number 2 is due tomorrow at 8:20, and I'm going to be grading your exit ticket for mastery. Again, that's due tomorrow at 8:20. As a reminder, you have more than one go at your exit ticket. At least you can do twice. So if you need to do it twice, do it twice. You get the opportunity. Don't pass it up. All right, so we'll be talking about mutations again. Again, our objective is to describe how mutations can affect protein and structure function. Our overarching questions for today are, what are the different types of mutations and what types of mutations are the most dangerous? Sorry, not the most dangerous, the most dangerous. So thinking about point and frame shift and thinking about your exit ticket yesterday when I asked which ones are the most harmful or detrimental, our goal today is to figure out, well, which type, point or frame shift, are the most dangerous to us, specifically in production of proteins. So right now, after I read this, you're going to work on part 1 and part 2 in your worksheet. If you go to Google Classroom, it's just the one titled unit, or this one, number 2, worksheet number 2. It will have today's date on it. And just complete part 1, which is a vocab practice. So what are the definitions of these vocab words? And then it's going to go into part 2 and part 3. This part, what your goal is to figure out on your own first, before I tell you what type of mutation is most harmful. And so I have given you the original. So this is like, let's just say we're looking at typical normal DNA. This would be our normal coding strand of DNA. This would be our RNA that matches TCG, matches with AGC. And these are the amino acid sequence that would be made to create our protein. So those are the typical. I have given you 2 different here types of mutations that could occur. The first type of mutation that's happening is a missense, meaning I am changing one letter, one base from, as the original was CCG, I changed it to a G. So you're trying to figure out, okay, how is that affecting the protein? And then the second type is a frame shift mutation, or a deletion. So I have deleted the A from the 6 base. So if you look up here, it should be TCG, TCG, A, and then I've deleted one, AC. And so you're looking for, well, what happens to the amino acid sequence when you delete and change different bases? And so these questions I'm going to ask you is, well, how many amino acids change? Well, you can count them. And so that's the first part. And from the end of this one page, you should be able to figure out, well, which one is more dangerous? How many? And the one that's more dangerous is going to be the one that has more changes in the amino acid sequence, because means your protein is going to be drastically different the more amino acids they change. The second part is just more practice. So again, I've given you the original strand of DNA. This is a picture of it. I've given you the original RNA sequence and the original amino acid sequence. And your goal is to figure out, well, if you have a mutation that's a silent mutation, so adenine A is substituted for the cytosine C at the 9th nucleotide, you'll go back up to the original strand. You'll count 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of C, you'll change it to A, and you'll write that here. And then you'll determine, well, what's the RNA sequence, and then what are the amino acid sequence using your codon table at the bottom. And that's it. So that's the instructions. Pause me now, go work on that, and then come back. Great, welcome back. Oops, excuse me. So you've already completed this. If you have not, go do that first. But I wanted to just talk about this. So looking at point mutations and frameshift mutation, we can see that frameshift mutation, there are 4 different 1, 2, 3, 4 amino acids that have changed. In the point or missense mutation, only 1 amino acid has changed. So when we talk about which one's the most harmful, the one that's most harmful is our frameshift mutation, because it changed 4 amino acids. So it's going to drastically change the protein and the phenotype of whatever it is coding for, whether it's the blood cells or brain cells or skin cells, is going to be drastically different than what it should be. So frameshift mutations tend to be more dangerous. Like I always say, there's never like it is always this. There's an exception. If we were to have a point mutation that led to a nonsense mutation, so there was a random stop codon, that would be more harmful because it's only making a very small part of the protein and not even completing it. So an exception would be the point to nonsense mutation. But in general, the most harmful mutations are the frameshift mutations because they move everything and they change many amino acids. That's the only new bit of information you need to know for today. You're going to go to Google Classroom, finish that exit ticket. If you have questions, I am on Zoom. I will go through the entire worksheet with you, and I'll be happy to make sure you get them all correct the first time so you don't need to redo it. So jump on the Zoom call, ask questions, or just come say hi. It's always nice to see you. But stay awesome, stay safe, and stay inside. I know it's hard. And have a great rest of your day.